Hello all, this is a demo video of RNN with an nadam optimizer. Previously, this is a continuation of the previous video. In the previous video, we have worked with the different optimizers, and in this work or in this video, we are going to work with nadam optimizer, and we are going to make a comparison of previous optimizers with the RNN algorithm we have made. For that, initially we are importing the libraries which we are needed. Then we are loading the data set. In this work, we are using the heart disease data set. The heart disease data set we downloaded from Kaggle. You can just give us a heart disease prediction. Kaggle means you will get this data set. The data set which we have used is having nearly 14 entries. Among that, the first 13 entries we are using as the X variable, and the last entry, which is the target one, we are using as the Y variable. Then we are getting the info of the data set. From that, we are getting to know that the whole peak is 1 is the fault type and all others are integers type, and then we are checking whether the data set is having any null entries. Since you may notice that everyone is 0, it is not having any null entries, and we are moving to the next stage. And if it is having any null entries, means we have to work with some pre-processing functions. Then we are displaying the heat map of the data set. So this is the heat map of the heart disease data set which we are using. Then we have determined the X variable and Y variable. As I said previously, for the X variable, we are dropping the target variable, and apart from the target variable, every variables are used as the X variable, and within the Y variable, only the target variable is used. And based on this X variable and Y variable, and the test size is 0.2, that is 20% for testing and remaining 80% for training, we are determining variables like xtrain, xtest, ytrain and ytest, and then we are using the standard scalar to conversion of vectors within the variables like xtrain and xtest. Then we are getting the shape of the data set. Xtrain, why? Because within this RNN layer, we will be calling this a layer, input layer size, extrain. But mostly with many RNN or neural network algorithms, it will work with only three-dimensional data. But you may notice that our data is two-dimensional. So we have to convert it into three-dimensional. For that, we are using this reshape function. This reshaping function is converting this two-dimensional data into three-dimensional. This three-dimensional data we are using as the input shape within the layer description of simple RNN layer, and the activation as ReLU. And since it's a simple RNN model, we are using only two layers, that is simple RNN and dense layer. The final dense layer is having only one output dimension, since our work is a binary classification work. If it is a multi-class classification work, this one will be replaced by the number of classes you are having, and mostly in binary classification work, the activation we will be using as sigmoid. And this is the summary of the layer contribution of RNN layers. Then we are compiling our model by using the loss as binary cross entropy, optimizer as Adam, and metrics as accuracy. Then we are fitting our model or training our model by using the fit function, and with the variables like xtrain, ytrain, xtest and ytest, and approaches for 50. Nearly for 50 approaches we are training, and we are determining variables like loss, accuracy, validation loss and validation accuracy. And then we have determined the classification report, and we have got an accuracy, precision, recall, F1 score, support, micro average and weighted average. Here every values is having more or less to 99%. Then we are making a definition for the confusion matrix plot, and by using this definition we are creating a confusion matrix for the Adam RNN optimizer. Then we have worked with SGD optimizer. Here the layer contribution, then compiling and all same only, but the only thing, not only only this optimizer. With every optimizer, the only thing this varies is the optimizer. Previously the optimizer will be Adam. Now we have replaced with SGD and worked for 50 approaches, and we have got the accuracy classification report accuracy as 88%, and we have displayed the confusion matrix. Then we worked with rmsprop, and for that we have replaced the optimizer as rmsprop and worked for 50 approaches, and we have displayed the classification report and also confusion matrix. Then with adadelta, for adadelta we have replaced the optimizer as adadelta, which is worked for 50 approaches, and the classification report showing that less accuracy only, which is 48%, and then we are showing the confusion matrix for this model optimizer. When the adagrad optimizer is implemented, here the optimizer place is replaced by adagrad. Then it is worked for 50 approaches, and then we are working the classification report and also displaying the confusion matrix. Then we worked with adamax. For that, here also the optimizer is replaced by adamax, and it is worked for nearly 50 approaches, and we have displayed the classification report and also the confusion matrix. In this work we are working with nadam optimizer. The layer distributions and all same only, but we will be differing the name because previously at the end we have to make a comparison. So if in that case the every name is same means we will get some confusion. So in order that the name will be differing but everything will be same only. First it will RNN, second it will be some RNN yes and all based on the names. Here it is, since it is nadam we have given as RNN, and the optimizer we have replaced by nadam, and it is working for 50 approaches, and we have got the values of loss, accuracy, validation loss and validation accuracy. So among the previous optimizer you may notice that Adam itself is showing only 99%, but with nadam we have got nearly 100% accuracy, and we have displayed the class confusion matrix also. Then we are making a comparison with an Adam optimizer. You may notice that with an Adam and this rmsprop mostly every this 2 to 3 optimizers training accuracy and validation accuracy or merging like that. 2 to 3 optimizers training loss and validation loss are merging. When coming to this adadelta, here you may notice that the here it is uh, very straight line, because if you notice means for other optimizers everything is having deviations, but for this adadelta this is straight. So by this we can make an comparison and some descriptions of which optimizers is providing better value, which is changing, which is not changing and all. In the next video we will be working with the fdrl optimizer, and we'll make a comparison regarding that. Thank you.